Alrighty then, this is day 2 of our unit as we continue to work with circles, but now we are focusing on the relationship between chords and arcs. In day 1 we learned about some of the properties of chords that exist, and we're going to look at some more properties, some more problems showing us how those things work. For example, this one. What we have here, even though the whole diameter is not shown, see how this is perpendicular and we have this dot here. So if I wanted to, I could extend this and you would see that it is in fact I could put a diameter right here very easily. Okay? So even though the whole thing's not drawn, the fact that I could put a diameter right here means that this is a perpendicular bisector. Okay? It's perpendicular, it's a diameter, so it has to be a bisector. So that simply means that if this is 6, then this has to be 6 as well. So x equals 6. And that's the answer number 1. So guess what? Number 2 is the same thing. If I kind of extend this to look at the diameter that's happening, this diameter is a perpendicular bisector. So if that's 3, then this is going to be 3. So x is equal to 3. All right, if only they were all that easy. They don't stay that easy. Let's see if it gets difficult yet. Okay. All right. Some kids have a hard time understanding what I'm about to show you. Let me zoom in just a little bit. All right. One of the key things I need you to hold in the back of your mind is the fact that any radius in this circle is going to have the same length. So when you look at a picture like this, I want you to focus on the radii. So like this is a radius. Maybe I'll make 3 different colors. Yeah. This is a radius. And let's go orange. This is a radius. All right, those are 3 radii that are shown in the picture. All 3 of these radii better be the same thing. Distance from the center to the edge shouldn't change if we're talking about a circle. So it will be useful to know what the radius is, because that's going to give us all 3 of these. Now this 31.8 is the length of the diameter. So let's go ahead and divide that by 2 and we will know the radius. All right, that turns out to be 15.9. So that means this is 15.9. That means this is 15.9. And that also means that this is 15.9. From there to there. Okay, because those are all radii. So guess what? We don't really need this 14.3. That's just there to distract you. You can just ignore that. All we really need is the fact that this is 15.9 and this part right here is 7. So if I want to find the other part, I can just subtract, because it sort of splits here. If the total is 15.9, if I take that 15.9 and I subtract the 7 part away from it, you know what I mean? So just imagine that if I took the 7 away, that would leave x. All right, so that's how I find it. So that is going to be 8.9. All right, so that should be x. All right, let's take a look at number 4. Okay, so x is this little segment up here. So guess what? This is going to be the same thing as number 3, because let me do my color thing again. Radii. We're told the radius is 9.7. That's why that's 9.7, and this is 9.7. Okay, that over there is 9.7. Everything I'm drawing here is 9.7 because they are all radii of this particular circle. All right, those are the 4 radii that are shown in the picture, and they are all 9.7. But of course, the one that I need is the purple one. Okay, so if I know that the purple here is 9.7 because it's a radius, okay, but then I know that this part down here is 5.1. You know, from here to here is 5.1. So if the x should be the part that's left over. So again, if I take the whole thing, the 9.7, and I subtract the 5.1, okay, then that's going to leave me with 4.6. So that should be the part that's left over, the x. So x should equal 4.6. All right, so notice, you know, they're giving us numbers that we don't actually use, like the 8.2. It's just a distractor. It's additional information that you don't ever use. So watch out for that. Kids get tricked by that sometimes. Don't fall for it. Don't fall for it. Let's see. Okay, so on this one, I kind of bet we're about to use the Pythagorean Theorem. I see the little right triangle there. So, you know, focus on this triangle. Now, once again, if you have a diameter and it's perpendicular, it has to be a bisector, okay? So this diameter, you know, if I were to continue to draw it, is going to be a perpendicular bisector. So that means the two sides are equal. So this 9.7 that we see over here, you know, this 9.7 is this length, that side over there. That means this side over here will also be 9.7, okay, because it's a bisector. So that gives us this side of the triangle. That's 9.7. I could also find this side of the triangle, you know, the hypotenuse, if I wanted to, by just dividing by 2. Okay, because 25.2, that's the whole diameter. So that means this part down here is going to be 12.6. So that just sets us up to do a nice little Pythagorean theorem. So if I want to find x, it is simply the third side of this right triangle. So I can just do x squared plus 9.7 squared is equal to 12.6 squared. So if I solve this, then that's going to give me the x. So what I like to do is just leave it this way for some reason. You know, I just like to type it all in my calculator at the end. You could square this and square that and subtract if you want to. You'll get the same answer as I do. So, but for right now, I'm going to have x squared equals 12.6 squared minus 9.7 squared. And then I would take the square root. So square root of both sides. And see, I just typed this whole expression in my calculator. All right, so that's going to give us, you know, in my calculator, it's doing 8.0417, you know, etc. Normally, I try to round this to 1 decimal place at a problem like this. But since this is just a 4, it's going to wind up remaining the same. So it's just going to be 8.0. Okay, so that's the answer number 5. Okay. Number 6. Let's see what's happening here. So that's 4.2. Same thing. Number 6 is pretty much the exact same problem. This 7.8, because this has to be a perpendicular bisector, If this is 7.8 over here, then that means this is going to be 7.8 over here as well. So this side right here is 7.8. 4.2 is just not relevant to this problem. The 18.8, so I'm going to split that in half, and that's going to give me 9.4. So this part right here is 9.4. And we are being asked to find x. So that's just going to be the Pythagorean theorem. So we will just do x squared plus 7.8 squared is equal to 9.4 squared. So that means we'll have x squared equals 9.4 squared minus 7.8 squared. And then we shall take the square root of both sides, yeah? So square root. And that will give us x equals, handy dandy calculator, 5.2. All right, so that is how you do number 6. All right, number 7. Okay. Number 7. It's looking like another Pythagorean theorem. Perpendicular bisector once again. So because this side over here is 10.6, that means this side right here is 10.6. Of course, right here, we're given that that is 4.3. And then we're supposed to find x. Okay, so we're just going to, it's just simply the Pythagorean theorem. So we're going to do, this time x is the hypotenuse though. So we can say x squared is equal to 4.3 squared plus 10.6 squared. All right, because that's our a and our b, and x is our c squared. But once again, if I take the square root of both sides, and then that's just going to give me my answer. Handy dandy calculator time. Bling! X is 11.4. All right, so far these have been kind of easy. I mean, is it just me? I mean, I know I'm a math teacher and everything, but even when I put my student eyesight on, it doesn't seem like it's been that tough once you see this. Like I bet you can guess what I'm about to do right now. It seems like the same problem over and over again. 8.3, once again, this has to be a perpendicular bisector. That means these two parts are going to be equal. So if this is 8.3 over here, then that means this is 8.3. Okay. And we're given that this is 4.4, and we're supposed to find x again. So it's just the Pythagorean theorem again. All right. I wonder if this guy really got paid for the inventing the Pythagorean theorem, Pythagoras, because we are really using it a lot. So x squared is equal to 8.3 squared plus 4.4 squared. You know, royalties, you know what I mean? His estate should get paid per use of the Pythagorean theorem. Anyway, so that's going to give us x equals, put that in your calculator, bling, 9.4. Yay. So, yeah, that's number 8. Fantastic. Number 9. All right, anything other than the Pythagorean theorem yet? No, not yet. Another Pythagorean theorem problem. So this is just going to be a squared plus b squared equals c squared. So x squared plus 8.4 squared equals 10.4 squared. That means x squared is equal to 10.4 squared minus 8.4 squared. Okay, taking the square root of both sides. Kabam. Bling. 6.1. Okay, that's number 9. All right. Will this once again be the Pythagorean theorem? Yes, it is. Once again, the Pythagorean theorem. Because once again, if, this diameter has to be a perpendicular bisector. So, yeah, if this is 10.8, that means this is 10.8. So here we go. X squared plus 10.8 squared is equal to 12.5 squared. So x squared equals 12.5 squared minus 10.8 squared. Take the square root of both sides. Handy dandy calculator. I'm getting 6.3. What do you make of that? Okay, and that is a 12 in there. All right, number 10. I think we're getting near the end. Well, kind of, sort of. Number 11. Will this be another Pythagorean theorem problem? No, it won't be. But it looks like it's just another subtraction problem. Hold on. Let me think. All right, finally a problem that's going to take something more than the Pythagorean theorem. Will we do the Pythagorean theorem? Yeah, we will do the Pythagorean theorem, but we will have to do another step beyond the Pythagorean theorem. So this may be the problem that you tuned in to see. So pay attention, slow down. It's all about the radius. Okay, we're going to actually wind up using both of these numbers. The radius here is 16.7. Keep your eye on that. I'm going to have to actually draw another radius that's not shown yet. I need to draw this radius that goes here. I feel like making it another color, though. Let's go with green. Not too much. Okay, I need that radius right there. Now that radius, of course, is also 16.7. So I know that this is 16.7. Now I've got the 15 over there. See, I'm just building my right triangle that I'm going to do the Pythagorean theorem on. Okay, that's 15, of course. Okay. Now, if I did the Pythagorean theorem, you understand I would be finding this over here, not the x, which is the other piece. But I'm going to worry about that later. So I can't use x because that's already taken for this piece over here. So I think I will use y. So I'm going to do this piece right here. I should be able to find this piece with no problem using the Pythagorean theorem. I'm going to call it y. So my equation is going to look like this. A squared plus b squared equals c squared. So y squared plus 15 squared is equal to 16.7 squared. Subtracting from both sides, that's going to give me y squared equals 16.7 squared minus 15 squared. Taking the square root of both sides, like so, that's going to give me y equals, and I turn to my handy dandy calculator. All right, y is approximately 7.3. All right, I did do a little rounding there. Okay, let me move the y over to this side for a second, because I want to put the number here. Hopefully you'll be able to see it better. So I now know that this red piece here is 7.3. Now, why did I do that when I'm really supposed to find this x over here? I'm really supposed to find this purple piece. Well, I can do what I did on a lot of these other problems from the front page. Okay, do you remember these problems? Where are they? Remember when I would do the whole radius and then I would just subtract to get the missing piece? Yeah, if I know one piece and then I know the whole thing, I can just subtract the one piece from the whole thing to find the other piece. So that's the situation I find myself in right now. Because I do know the whole thing. It's a radius. So I know that this whole radius is 16.7, just like this radius and this radius. So I should be able to subtract the 7.3 that I just found, and that will give me the missing piece. Okay, so that is one level higher, and I hope that you followed it. But let's go ahead and follow through and do it. So we will do 16.7 minus that 7.3, and that should give us our x. 9.4. Okay, that's number 11. Number 12. Number 12 is going to be the same thing again. In fact, okay, if you have not done number 12 yet, and you probably haven't, I want you to pause the video. I just showed you problem number 11. This one's the same thing. Pause the video and do number 12 on your own, on a sheet of paper, and then come back and see if you got the right answer or not. I'll wait. Okay, let's pretend that you paused the video like I suggested. Okay, because let's say, we both know that that was the wise thing to do. Whether you actually did it or not, is up to you. Okay, I really wanted this to be a different color. All right, so once again, we're going to do the same thing. So this radius, I had to draw it in myself to sort of build this right triangle. But I know because of this radius over here that this will be 15.1. I have the 12.8 sitting up there, okay, given to me. So I should be able to find this red side right here, no problem. Once again, I'm going to go ahead and call it y, because x is already taken. And bottom line, once I find it, I can just subtract it from the 15.1, and that will give me the missing x part. So, but first we got to find it. So, Pythagorean Theorem, y squared plus 12.8 squared is equal to 15.1 squared. That means y squared is equal to 15.1 squared minus 12.8 squared. Square root of both sides. Okay, so that's going to give me y equals calculator, and I'm getting 8.0 approximately. So that's this y value. That's not the final answer. I have to keep going until I find this x here. But I will tell you this, if x is this purple part right here, but I know the total. The whole radius is, of course, 15.1, just like this is, just like that is. All radii are the same. So if this y part that I just found is 8.0, I'm just going to go ahead and fill it in there. I just found out that this was 8. So if I want to find x, I should be able to do 8 minus, 15.1 minus 8. Let me switch to purple anyway. All right, so 15.1 minus 8. That should give me the x value. Okay, so that's going to be 7.1. All right, that is how you do number 12. So we're down to the last couple problems here. Let's see what they are like. All right, number 13 again is the same thing. If you have not done one of these problems completely by yourself yet, again, please pause the video and do that. Do number 13 by yourself. But I'm going to keep going. So, yeah, so what I have here is I have a radius, which I will color in green. If the whole diameter was 30, that means this is 15. I'm going to need that 15 later as well. 14.1. If this is a perpendicular bisector, then that means this is going to be 14.1 over here as well. So I could just bring the 14.1 over here if I wanted to, or I could have put my radius over there if I wanted to. Either way. And again, I will find this third side of the triangle, and I will call it y once again. So here we go again. Y squared plus 14.1 squared is equal to 15 squared. So that's going to give me y squared equals 15 squared minus 14.1 squared. So that's going to give me, because I have to take the square root of both sides, and I'm just going to put that in my calculator. All right, I keep talking about typing this into the calculator. If you're not one of my actual students, you might not know exactly how I intend you to do that. So let me just mention that I encourage all of my students to get the TI-30 XS multi-view calculator. It's only $15 and it does a lot for that $15. So when I say type it in, I'm just going to show it this one time. This is what I'm talking about. So I can just go ahead and hit second to make the square root, and I can literally just type it in just like it was on the paper. 15 squared minus 14.1 squared. All right, I can just type in that entire expression and just hit enter. So I'm getting approximately 5.1 out of that. Okay, so that's what I'm always talking about when I say just type it in your calculator. So that's giving me y equals 5.1 approximately. So I'm just going to erase that and put it right there for a second. So 5.1. Now remember that we are supposed to find x down here. And just like we did the last two times, we will pay attention to what the total is. The total radius, as you can see right here on the green, is 15. So if the total radius is 15 and this red part is 5.1, I should be able to subtract the red part to find x. So I should be able to do 15 minus 5.1 and to get my x. So what's that going to be, 9.9 or something? 9.9. Okay, is what I'm coming up with. So that's how you do that. Number 14 is the last problem. And it looks like it's going to be the same thing as the last three problems. So if you've still just been watching me do it and sort of copying off of me, shame on you, because you should have done the last two by yourself. But you still have a chance to redeem yourself. Please make sure you're doing these problems yourself. So pause the video, do number 14 on your own, and then check. But I'm just going to pretend like you did that. Okay, so I've got my radius. I need to build a right triangle. So I'm going to take my radius and slide it down here like this. All right, because I need to get my right triangle going. Okay, so there it is. So I know that since all the radii are the same, this green radius will be 18.9, just like the original radius was. You can see that this side of the triangle is 15.7 because it's right here. And we can find this side of the right triangle, and we can call it y. So that's going to give us y squared plus 15.7 squared is equal to 18.9 squared. That means y squared is going to equal 18.9 squared minus 15.7 squared. Time to take the square root of both sides. So that is going to give me, all right, again, I'm just going to put this in my calculator. It would look like this, and I'm getting 10.5. Okay, that is not the final answer, of course. That is this red part, and we are supposed to find this purple part. Okay, but once again, I know what the whole thing is. The whole thing is 18.9 because it's a radius, just like the green, just like the black. So if I now know that this red part is 10.5, I should be able to subtract. If I take the whole thing minus the 10.5, that should leave the x. So if I do 18.9 minus 10.5, that should leave me x is equal to 8.4. Okay, that is it for this lesson. I hope you found it helpful, and if you did, please go ahead and give me a thumbs up. Like me, lets me know that I'm appreciated, and I will thank you very much. So I will see you on the next video.